Hello and welcome to this recording for A-level math. What I'm solving today is an S2 exam. This is May June 2025, as you can see on your screen. Let's begin solving. Okay. Question number one. Yeah, I have everything in front of me now. At a certain shop, customers arrive independently and randomly at a constant average rate of 23.4 per hour. So this is a Poisson distribution. Okay, so find the probability that in a randomly chosen 1 minute period, so this has to change from intervals. I can divide 23.4 by 60 to find lambda. Okay, lambda 8. So that's 0.39. Okay, okay, so that's 0.39. Then it's asking me to find the probability that in a randomly chosen 1 minute period, at least two customers. So at least two means probability of x greater than or equals to 2. When I say probability of x greater than or equals to 2, it means 2, 3, 4 up till infinity. So I can't calculate that, but I can subtract the remaining from um, 1. So I can subtract 0 and 1 from this from 1. How do I calculate 0? So e power minus lambda 0.39 minus lambda e power minus lambda. Okay, so let's calculate that quickly on our calculator. I think I have probability distribution Poisson variable 1.39. So I'm getting 1 minus 0.9411. 0.0589. Okay, to correct to three significant figures. Okay, the random variable x denotes the number of customers who arrive in a randomly chosen 1 hour period. So 1 hour period lambda is 23.4. It's greater than 15. So we use a normal distribution. So x follows a normal distribution with mean 23.4, comma variance is also 23.4. Okay, mean and variance are both lambda. Use your approximating distribution to find the probability of x between 20 and 30. So if you're using the normal distribution, you have to use continuity correction because you are converting a discrete distribution to a continuous distribution. The continuity correction is going to be x has to be greater than 20, so 20.5, and x has to be less than 30, so up to 29.5. Okay, then you convert both to z values. Okay, let's do those calculations on our calculator. That gives me minus 0.595. 1.61. So because z has to be correct to three decimal places, I can say that this has to become 5995 should become 600. So it's phi of 1.261 minus phi of minus 0.6. Now I do the normal distribution in a particular way. If you're comfortable with that, just do that. If you're not, then use your own method. There is no harm in doing that. Okay, I think okay, now I have my formula sheet in front of me. Let me quickly turn to the table so that I can read the values for you. I have to read 1.261, so 1.26 and 1. Okay, so 8964. Okay, so that's 0.8964 minus 1 minus 506. What's 5 0.6? 0.6 should be 7257. So 1 minus. Okay, let's put all of that on a calculator. 0.8964 minus plus 57. I am getting 0.6221. That's question number one. Question number two says the lengths of pencils made at a factory are normally distributed. The standard deviation of the length is sigma, and the mean is supposed to be 10 centimeters. An inspector thinks that the mean is actually greater than 10 centimeters. So, this a hypothesis testing question. He takes a random sample of 50 pencils at the factory and finds that the length is 10.03. Then carries out a hypothesis test. He finds that the value of the test statistic is 1.995. Correct to 3 decimal places. Calculate the value of sigma. Now it's not asking you to do an entire test, but I think it's going to later do that. In any case, it's given you the value of the statistic. So z statistic is x minus mu over sigma divided by root n. That is how you calculate the z statistic. So 1.995 x bar, sorry, x bar 10.03 minus mu is 10. Sigma is the unknown here, and I have 50 here. Okay, so this is just cross multiplying and solving. So sigma over root 50, root 50 equals to 0.03 divided by 1.5 multiplied by root of 50. So that gives me sigma at 0.106. Correct to three significant figures. Carry out the hypothesis test. For the hypothesis test, I'm going to first write the mean. What does he think? He thinks that the mean is actually greater than 10 centimeters. He thinks it's an upper tailed test. Okay, so draw your critical region. Okay, what's significance level? That's 2.5%. So I'm going to look at 97.5% from here. It has to be 1.960. Okay, my z statistic, my test z value for the test statistic is 1.995. It falls in the rejection region. Okay, so reject h naught. Okay, there is evidence that greater than 10 vector is right. Okay, explain whether it was necessary to use the population central limit theorem. No, the distribution is normal. The distribution is normal. Therefore, CLT is not necessary. Okay, so quick question in terms of the working, although it's 7 marks, I didn't take 3 minutes to do this. Okay, a machine dispenses coffee into cups. The volume of a coffee is measured for a random sample of 150. The results were summarized as follows. Calculate unbiased estimates of the population mean and variance. So mu is basically x bar. So 46350 divided by 150. That's 309. Okay. For the standard deviation, we will have to unbias it. So n over n minus 1 into s squared. So that's 150 over 149. And the formula for s squared is going to be sum of v squared divided by 150 minus the mean squared, which is 9. Okay. I hope those calculations are correct. So 14410. Okay, I don't need this. I don't need the root right now because it's s squared. So that gives me 594.96 and rounds off to 595. That's sigma squared. Calculate 95% confidence intervals. So mu is going to be, what is x bar? X bar is 309, I think. Yeah. Okay, minus z value. What's the z value going to be? It's going to be 97.5% because I have to leave out 2.5% on both sides. So that's 1.96. 1.96 into sigma over root n. So it's going to be 595 over 150, I think. Yep. Calculate that. 305.1. Actually, to three significant figures, unless there's something keep three significant figures, then 313. Okay. Another random sample of n cups of coffee is taken where n is between 100 and 120 and 95% confidence interval for mu is calculated. Using this sample, you may assume that for large samples, unbiased estimates sigma square are very similar. Without calculation, state whether this confidence interval would be wider or narrower than the confidence interval found in part A2, giving a reason for your answer. Okay, so I have n as something less than 150, so the sample size is smaller. So you use the same mu, you may assume that sigma square is very similar. So since 120, 100 to 120 is less than 150, therefore sigma over root n is going to be a larger number. Therefore, confidence interval will move further left and further right, and make the interval wider. Okay, because you add subtract these if you understand that. So you'll be subtracting a larger number, you'll be adding a larger number as well, which means that you'll be more to the left and right in both directions. Okay, question number 4 says Emma needs to choose one person at random from these three people, P, Q, and R. She plans to throw two fair coins and for n of heads. If n is 0, she will choose P. If n is 1, she will choose Q. If n is 2, she will choose R. By considering probabilities, show that the choice made by this method is not random. For it to be random, all three probabilities should have been the same. Let's calculate the probabilities. Okay, so you'll get probability n as 0 when she gets no heads, right? 25 point and no. So tail and tail, probability of tail and tail. So half into half, 1 over 4. If she gets to get one head, so it's head into tail, but they can switch around, so into 2 factorial. So half into half, the 2 factorial gives me half. And as 2 will mean probability of head and head, so half into half, 1 over 4. So Q has a greater chance of being chosen. Therefore not random. Data Emma has to choose 2 people at random from 3 people. Describe how Emma could use a single throw of a Faraday's 6-sided dice to make this random choice. Okay, so we can make groups actually. Okay, so she can make groups. So let's say PQ, PR, and QR. Okay, so let's say you get number 1 and 2, so you choose PQ. If you get number 3 and 4, you get PR. And if you get number 5 and 6, you get QR. That way, all probabilities will be equal. 1 or 2. Let's say 1 or 2, not 1 and 2. 1 or 2, 3 or 4. So that I'm adding up the probabilities rather than multiplying. All probabilities will be equal. Okay. Okay, in Herbaria, the masses in kilograms of men have the distribution this. A certain footbridge is Herbaria can take a maximum safe load of 1500 kgs when n stand on the bridge. Probability that the bridge is unsafe is less than 0.01, stating a necessary assumption. Find the maximum value of n. So number of men is random then. Okay, so we're not biased towards heavier men or men with less weight. Chosen is random. Okay, so I will have to construct the distribution for nn, which means that I will have to come up with the mean, which is 70.3n, and the variance will also multiply with n. Okay, I want the probability of that nn is unsafe. That means it has greater than 1500 mass. The probability is less than 0.01, so less than. Okay, that is the equation that I'm trying to solve. Okay, let's see what I can do. Say that z 1500 minus 70.3n over 5.9n squared in a root is less than 0.01. Okay, we're solving for n. We'll look at that. 1 minus that should become 5.9 root n. 0.99. I hope my inequality works. So it's phi inverse of 0.99. 2.326. Cross multiplying. Okay. 13.7234 root n. Squaring both sides. One 188.33. 1500 squared. A very long calculation. 4942 squared. Okay, so bringing everything on one side then, 4942 4942.09 n squared plus n, two negatives, 10900 minus 3 2110883 n plus 225. Okay, so what I am then going to do is I'm going to try to solve a quadratic. I can do calculate question, and I've done enough working for me to get marks. So let's quickly put that on my calculator. I can, at the end of the exam, I can come back and write the quadratic formula if I think that's necessary. 2254. Okay, so I'm getting n as 22.2526 or n for 5. Okay, okay, since this was an inequality, I have the quadratic curve that looks like this. Now it's obvious that what I should be thinking about is a maximum value. The quadratic inequality is certainly giving me these two answers. Okay, but I know that there has to be a limit on the number of men. So I'm going to say it's this part that's the limit on the number of men. It's certainly, if you exceed that, then definitely going to get a higher weight. Why am I getting this? Because I had a quadratic equation, and quadratic equations tend to answer. Okay, so your answer has to be n is less than 20.45. Okay, when n is less than 20.45, then the maximum value of n 20. Okay, again, if you also test out these two values, remember that equations with roots tend to have one correct answer. So if you would have plugged in 22.45, I'm pretty sure this wouldn't have worked. Okay. Okay, a random variable x has probability density function given by this, where a and b are constant. Show that a equals 2 over b squared. So I will integrate over the entire limit. Say that this has to be 1. So ax square over 2 limits is 1. So ab squared over 2 minus a0 squared over 2 to 1. So ab squared over 2 is 1. A equals to 2 over b squared. That was an easy proof. Continuous random variable. The probability of x is less than ex is 4 over 9. That's a 6-mark question. So let's first calculate ex. Okay. For ex, it's integration over the entire data set, and it has to be x f of x. Okay. So 0 to be x into ax. It's going to be ax squared, so it's going to become ax cubed over 3, 0 to b, ab cubed over 3 minus a0 cubed. That's ab cubed over 3. Okay, that's probability of x by e of x. Now, what am I trying to calculate? I'm trying to calculate the probability that I can also actually do this. Since a is equals to 2 over b squared, so 2 over b squared into b cubed over 3. That sort of simplifies this for me. The expected value is 2b over 3. I'm asking you for probability of x less than 2b over 3 to be 4 over 9. Okay, so what I'm going to do is I'm going to integrate from 0 to 2b over 3. What am I going to do? I'm going to x, okay, the function. So ax squared over 2, 0 to 2b over 3. Okay, then a 2b over 3 squared over 2. The 0 part is that out. So a is also what? A is, I just proved a as 2 over b squared. B squared, b over squared into half. Let's see if all of that cancels out and I get my answer. So that's 4b squared over 9b, 4 over 9. So I have the probability there. Question number 7. I don't know. There are 8 questions to this. No, there's 7 questions. That's the last question. In the past, one quarter of job applicants at a certain firm had first class degrees. A change made in the job description, and the director of the firm believes that on average, the proportion of job applicants with first class degrees has decreased. Okay, so he's doing a hypothesis test. Okay, in the month following the change, there were 35 job applicants. So there's a trial going on 35 job applicants, and all of these had first class degrees. The firm carried out a hypothesis that the 4% significance level to test directors' belief. Use a binomial distribution to find the largest value of or that would provide sufficient evidence that the director's belief is correct. Okay, so now this is a complicated question. Okay, in the past, let's read it again. In the past, one quarter of job applicants at a certain firm had class. So P was 0.25. Okay, so the director is trying to do a hypothesis test. Does it say anywhere that I want to do an hypothesis test? No, but I'm still going to do it at 6 marks. I need to write down my numbers before I can continue. Okay, so what is the director saying that this has decreased? So this tells me it's a lower tailed test. So my probability is going to be less than or equals to something. Okay, then what did I do? I did a test statistic. I did a test. I had N is 35, and all of these had first class degrees. So R is the test statistic. Okay, use the binomial distribution. So what I have to calculate is I have to calculate the probability of X less than or equals to R and show that it provides sufficient evidence. That means it lands in the rejection region. To land in the rejection region, I should be less than 4%. Okay, so what I will have to do is I will have to do a bit of trial and error in this question. I can't say for sure what R is going to be, but I will try out with some numbers and see. Okay, 35, a proportion of 35, let's say I calculate what's 35 times 0.25, a quarter of 35 is about 8.75. Okay, so what I'm going to do is I should technically start off with X is less than 8, but that's too large a number for a binomial. Take me a lot of time to write down the binomial. So I'm going to start with a reasonable number. Let's say I start off with 4. Okay, I want to find the largest value. So as soon as I come close to 4%, that should be. Uh, let's not start with 4. We're going to get confusing. Let's start with 5. Okay, so what I want to calculate is probability of 0, 1, 3, 4, and 5. Okay. Okay, so technically I should be writing this 35C0 q power 35 minus 0 and power 0. Okay, and so on for 35C5. I have to add up all of these as well. Now you see this is tedious, but I have my calculator. I can sort of still do a lot of cumulative things here. Okay, so this all of this probability comes out to be 0.09. I am looking for something less than. So okay, so I will decrease that number. I will say that's very large. Let's go down to 3. Okay, let's accumulate up to 3. The probability of X less than 3, 0, 1, 3 adds up to what? Adds up to 0.0136. That is less than 4%, but I will have to check if N would be 4 as well. Okay, so I just calculated probability of X less than or equals to 4, and that came out to 0.041. So no, this is outside rejection region. So what is the greatest possible value of R? The greatest possible value of R is 3. R is 3. Okay, I hope that's the correct answer. Let me, yeah, maximum value of R is 3. Why? Because that's the only number that's landing in the rejection region. Then it says in another month, the director carries out a similar test at the 4% significance level using the 35 job applicants from that month. Explain the meaning of a type 1 error in this context. Okay, so what is the type 1 error? Type 1 error is rejecting H naught when H naught is true. So the manager concludes that proportion has decreased, and it is actually Okay, given that the proportion of job applicants with the first class disease is actually 0.05, so when I give you a new proportion, you are supposed to find a type 2. So that's what the question is telling you. What is the probability of type 2 error? The probability of type 2 error is probability of acceptance region using new values. Okay, so the rejection region was r is x is less than or equals to 3, so greater than 3. Okay, and I'm going to use new values, so it has to be the probability of 4, 5, 6, 7, 9 up till 35. That's going to be challenging, so I'm just going to subtract 0, 1, 2, and 3. But remember, this is not the old probability that you can borrow. You have to use the new proportion that you've been given. Okay, so the proportion has now changed. It's 0.05. I want to accumulate up to 3. So 1 minus 0.9042. 0.0958. Okay, that brings us to the end of this exam. I hope this was productive. If you don't know a topic, please go back and watch the video topics. And thank you for watching.